There are a bunch of corner and edge cases in every problem, of course. And with the dependency injection and IOC container, when it comes to auto-wiring the dependencies, of course, there will be a bunch of edge cases that, because we are offloading the responsibility of dependency injection to the third-party tool, which is Spring here, we must be able to also configure and tell the Spring how to resolve those edge cases. And I just want to real quick enumerate the edge cases, a bunch of edge cases. And in this session, we will only tackle one of the most important ones. And we'll see how Spring provides a bunch of solutions to actually solve and resolve the issue. So one of the problems with dependency injection in general, actually, these are not because we are using a third-party tool. These are in general when you design a class, and for example, let's say you have the constructor in this class and you have another constructor in your dependency class. When inside the dependency, you also create a dependency from the dependent, you actually create a circular dependency. So you are inside your constructor, you are constructing and instantiating other object, and that other object inside its own constructor is instantiating an instance from you. So it will be a circular dependency, and there are a bunch of solutions for that, and that is not the matter that we are going to discuss in this session. The second type of the problems and edge cases with dependency injection in general, again, not because we are using Spring, is something as we call the partial injection. And that is when that situation rises when the dependencies cannot be fully injected in the configuration time, and let's say from the constructor. And for example, one of the types of the situations that partial injection rises is something named as widening scope. And with widening scope, what it means that it rises when a bean and the dependent one, a bean, depends on another bean with the narrower scope. So let's say that you have a wider scope, you are singleton, and you have a dependency which is prototype. If inside the singleton dependent, you need multiple instances from the dependency, which is having the scope of the singleton, then because it will be only injected once, you must find a way to access multiple instances and create an instance each and every time from the bean definition. And Spring provides a bunch of solutions to that. And the first one is actually asking for the application context from one of the injection points. Let's say that we have the engine is the prototype, has the scope of prototype, and the car has the scope of singleton. So we have an engine here, and let's say that every time the start method that will be called, let's say that we need, for whatever reason, we need a new engine, we need an engine. So we asked for the engine and we start the engine. And let's create the method. Okay, it doesn't matter. And because the engine will be injected only once, and every time you call this method, it will be called the single one that has been instantiated at the injection point, at the configuration time. So let's say that we need a new engine each and every time the start method is called. One solution to that is, instead of auto wiring like this, we could ask for the application context. We could ask for application context, like have a field here, or implement the application context aware interface, or let's have a field, or add the application context here as a parameter to the constructor or a setter method. Let's add it here, private application context, and let's put the auto wire. And because the application context itself is a bean, here we could get rid of this, and here actually instead of getting the engine, we could say application context.get bean of the engine type. Sorry, engine type. And that is absolutely a solution here, engine. And because we are accessing the application context and calling it every time, it will access that bean definition and will create a new instance. So, but this solution is not a preferred solution because again, we are coupling ourselves to the Spring. The second solution, which is a preferred solution, is that instead of doing this, let me put the out of wired again here and get rid of this. So instead of doing this, we could say that there is this interface. As you remember, we had the interface, the optional interface that we could wrap the type of the injection point and ask for a null value as well. But here we could wrap it to the ObjectProvider interface and tell that instead of injecting the real instance, we want you to inject a handle to the bean definition. So each time that I call this handle and ask for an object, this will call the application context on our behalf and get a new object if the scope is prototype, or get the same object if the scope is singleton. So by wrapping it to ObjectProvider like this, and we should call the method named getObject. So when we call the getObject, this engine is not the real instance anymore. It has a bunch of useful methods that we could say if the object is available or not, or ask for the object. So we are asking for the object each time, and because we are asking for this, it will go and access the bean definition each and every time and grab a new instance for us. And if we want to prove that, let's do an ugly thing here and copy paste it here. And okay, let me run it. I want to prove that we have two engines here. So because we have asked the get object once here and once here, the one that has been here is another object. You can see the address is different, and this one is a different object because by telling that we need the bean definition itself, not the real instance, not the single instance. By calling the get object, we are accessing and we are getting and we are querying for a new instance. There is other interface that we could wrap inside the object provider instead of the object provider, and that is the provider from the javax.inject, and that comes from the JSR 330, I think. And that is the same, that has the same effect like the object provider. So again, if I run it, you'll see that we have two separate engines inside the car class, and so that situation actually is resolved. Now let's get to the last and third solution, and that is inside of asking for a dependency like this. Let's say that we create a method and engine, let's say engine get me engine, okay? And let's say that instead of asking the dependency from all those injection points, we will ask the dependency from a method like this, get me engine, and get me engine, okay? Now it has to return an engine, but again, if we return something, it will return actually, if we cache it and return it, it will return the same one. And if we create one of our own, then again, we are not using the IOC container. if we want to ask the IOC container to resolve this dependency, we have to use this method that they call method injection. So by annotating it with @lookup, and we have to provide a dummy implementation, because this implementation will be ignored by the IOC container. This method is called this pattern is called the method injection. So what it does, that every time we ask and we call this method, instead of running its own logic, it will just go to the IOC container and it will try to resolve and find a bean that has the type of engine each and every time. And because we have called it twice, you can see that each time we are getting a new engine here, and that is another solution. So yeah, this problem and this edge case that is named widening scope is solved by reinjection. So these solutions were all categorized as reinjection. We are every time reinjecting, and these are the Spring solution for reinjecting a narrower scoped dependency into a wider scope dependent.